For 6-hole DCP, if you are using a small fragment, we will require a 2.5 drill. However, if you want to use it, or if you want to apply a lag screw for a fracture, then you will also require a 3.5 mm drill as well. Now, this is the depth gauge, we know about it. This is a guide which is extremely useful. There are two different holes. This is the centric hole, in which the hole is in center, and this is an eccentric hole, in which hole is slightly off center with an arrow, and I will talk about it when we use the plate. This is another drill guide or drill sleeve. On one side it says 2.5 mm and other side it says 3.5 mm. This is you are required to use this when you are applying a lag screw, and if I make a video about lag screw, I will show you how to use it. This is the tap. So if you're using a small fragment set, your screw will be 3.5 mm, hence you will be using a 3.5 mm tap if you are using a non-self tapping screws. This is a hexagonal screwdriver. These are bone holding forceps, these are plate holding forceps, and these are plate benders that we need to use if you want to pre-bend the plates. So this is a typical screw box for a small fragment set. You will see it says cortical 3.5 mm screw. It says locking 3.5 mm screw. If at all you need to use a canceller screw, then you have got a 4 mm screw. So this is your armamentarium if you are using a small fragment set. So I have simulated a transverse fracture on this particular bone model, and I will show you if at all you want to reduce it, and if you want to create a compression at the fracture site, what is the sequence of the screw and how to do that correctly. So we have reduced this fracture and we have used a plate holder in order to hold our 6-hole DCP. So you can see that there is some gap at the fracture site. So if you want to create a compression, then if you are using the system correctly, this gap will reduce, and then this will encourage primary bone healing. So if you are dealing with a transverse fracture, you can use a first screw should be a centric screw. So if you're using a centric screw, you will be using this guide and you will be putting a centric hole. Now if you're dealing with a transverse fracture, it doesn't really matter whether you're putting a centric hole on this side of the fracture or this side of the fracture. You can use any of it. On this occasion, I'm going to use this screw, and I'm going to use a centric screw on my left hand side. So if you look at the edge or the other side of the centric screw, you see this, it's oval shaped. So when you're using it, this should nicely seat into the plate so that it is drilling at the right place. Don't put it superficial. It should engage right into the plate. If I show it from the other side, Varun, if you can show it, this should go deep into the plate. It should not be out, otherwise then it won't work perfect. So just make sure it is seated well. So now I am in a position to drill, so I am just going to make my first hole centric hole. So if you use this system correctly, this hole will be bang in the center of this hole. So next step will be to the length or measure the length of the screw. So if you are using a non-tapping screw, then you need to tap. On this occasion I have measured the screw. My screw size is around 24. So if you're using a self-tapping screw, always use 2 mm more. So if you're measuring 24, you are using a self-tapping screw, use 26. On this occasion I am just using, to show you, the next step is to tap. So when you tap, make sure that you go few times and then just reverse. That clears the debris. This way it makes your job easier. So go in few times, then reverse. Go in few times, then reverse. Go in few times and reverse. This is the correct way of using the tap. Your next step will be to put the screw, the centric screw. So now to create a compression we need to use an eccentric screw. So now you can see this is an arrow. Now it's extremely crucial that the arrow is facing towards the fracture. It is currently facing away from fracture. So I'm just going to rotate it, and now I'm making my drill face towards the fracture. If these are the small things, if you don't care for this, then you may not get the desired results. If you're using an implant, you may, as usual, you may use it correctly so that you get the best results. So same, let it engage deep, this facing the fracture. You can use any hole, but on this occasion I am using a hole close to the fracture site, and again I'm going to drill it. So now on this occasion you can clearly see the hole is on one side. So what it's going to do is, once we put the screw, this is going to push the plate this way, and that is how it will create compression at the fracture site. So let's start putting the screw. So now I have tapped it. I'm just going to put a screw. Now this is our eccentric screw. Now key is to keep going, and once you hit the second cortex and you think you need to tighten the last bit, then you need to release this so that the bone can slide. Otherwise, if you're holding the plate tight, it will not compress. So I'm just going to tighten it, and you can see the fracture gap is nicely closing and it's rock solid. You can see the gap, if you can show it from the top. It's a plastic model, so it's not as great on this side. If you look at here, this is completely compressed. So this is how you use it. However, if you're not satisfied and if you want to create more compression, then there is another trick which you can use, and I will show you how you do it. So we first put a eccentric screw here. To create compression, we put eccentric screw here. If we want further compression, we are going to put an eccentric screw on the side where we put the centric screw. So again, the key is now the arrow is facing towards the fracture. I have changed it so that it's facing towards the fracture, and then put the drill. So now you can see I have put an eccentric screw here. So now I have tapped it. I'm just going to use the right size screw. But before I tighten it, you loosen the first centric screw few threads, just little bit. And then tighten this. And this will give you more compression. And you can see so finally we are going to tighten the screw that we loosened. So now next step will be to just put centric screw and fill all the holes. Now this is how it's looking. It's very difficult to reproduce in a plastic model, but this is the gist that I want to get you across, that if you use this in the real life patient, you will get compression. So initially you can see it's nicely compressed here, nicely compressed here, nicely compressed here, same here, nicely compressed here. If you see gap on the side where the plate is and gap here is a bit different. So you see that this side is opening a bit more, and that always happens, and this is the reason we advise people to pre-bend the plate. If you pre-bend the plate and then apply the same principle, you will get an even compression both on this surface as well as this surface. So the previous video was a demonstration of how to create a compression if the fracture was transverse. If you have a oblique fracture or a spiral fracture, then if you want to use or if you want to create a compression, then order of screw placement becomes extremely important. So if you are dealing with a fracture like this, and this is your, say for example, 3.5 mm DCP, then I would first put a screw. So I would first put a screw here, and this will be a centric screw. And the reason I will put this screw here is because the plate here comes in close contact and the fracture line is in this pattern. As soon as I put an eccentric screw, this fragment will go in this direction and will go inside this axilla. So this creates an axilla, this, and in which this fragment will go in. If we do it other way around, if we use this screw first, say for example, this is a centric screw, and then if we use this eccentric screw, this will create a compression here, but this is an open arc. So this axilla is open, it's an obtuse angle. So what this can do is, this can slide here. So the fracture can have tendency to, instead of coming like this can slide. So if you're dealing with oblique fracture, try to use that fracture configuration in order to create a good compression at the fracture site. So order of the screw placement that you will be using in the large fragment set is, one is the smaller one is a 3.2 drill bit. So if you're using just a plate, then this is what you're going to using. You will use a 3.2 mm drill bit. If you are using a lag screw and if you're using a fully cortical screw to lag, then apart from 3.2, for gliding hole you will also require a 4.5 mm drill bit. So this is a 4.5 mm drill bit. As in small fragment, this is your guide with centric and eccentric screw. So this is big enough to take a 3.2 drill bit. So again the principles will be same as in small fragment, that first place a centric screw and then eccentric screw. The arrow should be facing the fracture site. If you are using a lag screw, when I make a video of a lag screw, I would use this drill guide. So if you see 3.2 drill bit, it's mentioned here. So this takes the smaller one. So this is for your pilot hole, and for gliding hole you will be requiring a 4.5 mm drill bit. This is the depth gauge. This is a countersink. This was missing in the small fragments. If you're using a lag screw, it's extremely important, especially if you're using a neutralization plate on top to bury the screw head. So you need countersink to bury the head. This is the tap. As it is a 4.5 system, the tap will be a 4.5, and again this is a hexagonal screw for a 4.5 cortical screw. So as a part of large fragment set, you will get this bone holding forceps. This is helped in reduction, and then these are the plate holding forceps. If you look at the screw system here, if you are using a only DCP, then you will be required to use this 4.5 mm cortical screw or a 6.5 mm cancellous screw. However, if you are using a LCP, then you get 5 mm locking screws as well. Just to reinforce, if you are using a large fragment set, you are using a 3.2 drill bit. So if you are trying to create compression, first hole, as I showed you in the small fragment, will be a centric hole. This is a transverse fracture, so you can use it on any side. So on this occasion I am going to use this side. So I have used a centric hole here and it is bang in the center. Next step will be to measure the depth and then tap and then put appropriate side screw. So this is our guide now, and you can see this is a guide for an eccentric screw, and arrow is facing towards the fracture site, and again this should go, end of it should go completely into this plate. So now I have put an eccentric screw, and this you can see is on one side, it's not in the center. I forgot to show it before putting the screw. Now once I have engaged the second cortex and about to do the final tightening, it's extremely important for you to let this go so that bone can slide. It's a very plastic model, it's very flimsy, and hence whatever I want to show, it's not coming as good as it should be, but the principles are same. If you use it in your real life, it will be you will get excellent results. So I'm just going to give a final tightening, and I can feel it getting nicely compressed. So now you can see once I have created compression, this fracture is nicely compressed here, nicely compressed here. Only on the other side you see there is still some opening, and if you want to avoid that, as I said, pre-bend the plates. So it's extremely important that if you want to have even compression at the tension as well as the other side, then pre-bend the plate slightly to get an even compression. So this is how you put a DCP in a large fragment.